And we're back now talking about special methods, also known as magic methods. These are things behind the scenes. They're all dunder methods, start with 2 underscores, end with 2 underscores, that work some magic in Python. So in this example, the plus sign, 8 plus 2 ints versus 8 plus 2 the strings. How is that working? How does Python know what to do? And it comes down to the fact that this plus sign operator behind the scenes is actually resulting in this dunder add method, a magic method, a special method that's called. And it's called on this first operand, so in this case 8, the integer, and the method add is defined inside of the integer class, and it says, all right, if I'm being added to another integer, then we should return our sum. Versus on the string instance, the double underscore add magic method is defined, and it says if I'm being added to a string, then concatenate the two of us. If I'm being added to an integer, throw an error. So we can actually go and write our own add, and we're going to do that in just a moment, for a human class, so we can add 2 humans together. But other than add, we've actually seen some of these like len. When I introduced back in the built-in function section, I talked about len, the built-in function, and how it uses the dunder len, double underscore magic thing. So we can define our own len like this on a human. So when I call len on Colt, which is a human, I'm not 60 inches tall. I don't know why the slide says 60. Anyway, let's say I am 60 inches tall. That's going to be my length that's returned here. And, we could define whatever we wanted. We've also seen that by default, when we print out, an instance of any class we define, we get this really gross looking thing. We can use representation method, define that, and whatever we put in there, the representation will be called whenever we print it. And we've also already seen that. Okay, so the point of all of this is to show you that there are these built-in dunder, special, magic, whatever methods that Python uses behind the scenes that we can actually add to our own classes, implement them so that our classes can play nice with the rest of Python. So I'm on the documentation, and there's a section called special method names. There's a bunch of them. Init is one. There's, I'll point out some of them. We've already seen this one. Representation. There's also string and format. These all kind of have to do with representation. There is a slight difference. Representation is supposed to be sort of a Python expression, something that could be turned into Python. So it's actually not supposed to be a string like, hello, I am a human. It's supposed to be more Pythonic versus .str under the dunder method. We can put whatever we want in there. There's no expectation that it return a valid Python expression. But really, it just gets complicated. It doesn't matter. We can use whatever we want. Anyway, there's other things like len that we've seen. There's, keep going down here, reversed to return the reversed version of an iterator. Then here's the math ones. Add, subtract, mul, let's see, true divide, power. Basically, we can define how all of these should work. And these are used behind the scenes, of course. So we're not really doing anything new. We're just adding these methods to whatever classes we define. So let's do that now let's start with add and len and some of the basics. Here I have an empty file. I'll define a class called human, and we'll define our init. It'll be very simple. We need self, and then we'll have a first, a last name, and an age. And then we'll just set self.first equals first. Then let's do self.last equals last, and self.age equals age. Okay, let's start with the very basics, representation. We've already seen this. And let's just return a string, an f string, with the first and last name. Human, named, and then do, what do we have? Self.first, self.last, just like that. And now we should be able to make a new human. We can do j equals human Jenny Larson, like that. And she is 47. And now if I print j, we get human named Jenny Larson. Okay, so that's review. We can also do things like len. And how would we want to define the length of a human? I don't know. Let's for now just return self.age. So the length of time they've lived. How about that? So now if I do print len of j, we get 47. And if I hadn't done this and I tried to print the len of j now, we get an error because it says object of type human has no length. So it doesn't know what to do. So we have to add this in if we want to be able to call len on a human. Next, let's do something a bit more fun. Let's do add. Okay, so let's only worry about add between two humans. So if we add one human to another, a special thing happens and a third human is born. That's all I'll say about that. I don't want to get any bad reviews about that. So in our version, any two humans that are added together, it should return a new human that's 0 years old. And let's just have it take the last name of the first human. So it doesn't matter if it's a male or female. We're not getting into the politics of that and taking names, but let's just say the first human. So if we had J plus, and then let me make another human called human, I'll call him K, which is Kevin Jones, who is 49. Okay, so if I do J plus K, we're going to take the last name, so Larson. So it'll be a new human just born with no first name yet. We'll set first name to be unnamed or something, or newborn. How about that? Newborn Larson, 0 years old. So all we would do, we have to add self, and self refers to whatever came first. And then there's a second parameter, which I'll just call other. It's the second thing that's being added. And if we do this, we can add a little check in if we really want it to be fancy. We could add a little check to make sure it's a human. So see if other is a human, because self is guaranteed to be a human because this method is defined on human. But we want to make sure that we're adding a human. So is instance other human. If that's the case, we just return a new human where first is equal to, let's just go with newborn. Last is equal to self dot last. So whatever, J's name or the first human that's being added, their current last name, and age is 0. Okay? And otherwise, let's just return a string that says, technically I don't think Python wants you to do this, but just for our example, we'll return a string that says you can't add that. Okay. So let's check it out now. So we have J and K. Let's do a print J plus K. And on top of this, so if this works, J plus K should return this new human, and we should only see the string representation of it. So it should say human named newborn Larson. Let's check it out. There we go. Sweet. And we could, check the age. Let's do this. Human named aged self.age right there. Now we get human named newborn Larson aged 0. Cool. So we have addition working between two humans. If I tried to do J plus 2, for example, we now get a string. You can't add that. So that's add. One more fun one we could do is multiply. So the magic method for that is mul. So we'll do the same thing, self and other. So this would be, what if I multiplied J times 2? Let's say that we want to return a list or let's say we're cloning humans. So if I multiply a human by 2, it should be twins or triplets, something like that. So in this case, self refers to the first operand, and then other is the second one. And we could just start super simple with return, you are multiplying humans, like that. And if I print J times 2, we get you're multiplying humans. So this is just a shortcut for then calling the magic mul method wherever it's implemented. In this case, it's checking on human because it's on the left. If I did switch it up and do 2 times J, it's going to look on the int for the mul method, and it doesn't find it and freaks out. Okay, so the order definitely matters. So what we want to do, this will be a bit of a tangent here, we want to basically, however many times other is, in this case 2, we want to make 2 copies of J, of self. And we could just do a list comprehension for that. And we should start by checking if it's an instance of int. If is instance other, this time we want to int. If that's the case, then let's return, we'll do a list comprehension, and our list will just be self for, I don't know, I in range other. So it's just going to return self, which is J in our case, or whatever human, each time for I in range other. So other is 2. So it should return 2 versions of self, 2 J's in a list. And let's just do an otherwise return can't multiply. Let's check it out. What do we get? Human named Jenny Larson, age 47. Human named Jenny Larson, age 47. So 2 of them, and we're getting that because of the representation we set up. It's worth noting, well, first, let me just try multiplying it by a letter, for example. We get can't multiply. But it is worth noting that the way this is set up, these 2, or however many things, let's do 3. And let's save it to a variable this time. Let's say triplets equals j times 3. Okay. And if I just print triplets, and before I do that, let's try and change one of them. Let's change the middle one. So triplets, it's a list, so I should be able to do 1, 0, 1, 2. Triplets 1 dot first, should have a different first name. Let's see, Jenny, and they're identical triplets, so let's go with Jessica. So the second person, the second triplet should have the name Jessica, but if I look at it, they all say Jessica. Human named Jessica Larson, human named Jessica Larson. And what's happening is that these are all the exact same object. We didn't make actual clones or copies. They are identical and they're linked. So when we make a change to one, it's made in all of them. So this list is just 3 references to the same thing because we're just returning self. So this is where I'm getting into a tangent, but if we did want to make this actually work with the functionality we want 3 copies. We can import from copy, so this is a built-in module, we can import a method called copy. And then what copy will do, just pass in self, it will actually make a new copy, a new space in memory for each copy. So they are separate. They'll start out looking the same, but they're separate. So we have to import it first. And now if I try it, oh, it did not need that. If we try and change the second one's name to be Jessica, there we go. Human named Jenny Larson, human named Jessica, human named Jenny Larson. So now we have triplets, and they are all different. So our multiply is working. And finally, we could do a little longer math equation. What if we did this? We have k, so let's do k plus j, like this, times 3. So this is Kevin and Jessica having triplets. So they do whatever they do, and we get the add, which gives us a newborn, 0 years old, with the last name of Kevin this time, which is Jones. And then we're multiplying that person, that human, by 3. So we should get a list. So let's do triplets equals k plus j times 3, and then print triplets. Whoops. Let's comment this out. And what do we get? Here we go. Human name newborn Jones, age 3. Newborn Jones, age 3. Age 0, 0, and 0. We get 3 of them. Okay, so it's kind of fun. We're now just coming up with all different math that we can apply to humans. I will leave it at that because it gets a little grimmer when we talk about subtraction and dividing up humans. I'm not going to go into that. So we have addition and multiplying, but the real lesson behind all of this is that there are these magic methods, and something like the plus sign is going to call magic method, special method, dunder, add. It's going to look for that. If it doesn't exist, then it's going to throw an error. If it does, then it's up to us to determine how it should work. Or it's up to the string implementation or int to decide how it should work.